Nvidia launched a new GPU today, or at least officially announced it, and it was buried in the bottom of a press release email, and I get these all the time about just which games are getting DLSS updates, but there it is. Now, finding the official post about it was also a little bit rough because it's buried in a post called Conan Exile's Enhanced GeForce Game Ready Driver Released, and as you scroll down, you eventually see the announcement about a new laptop GPU with more VRAM, which is actually kind of a big deal. Now, GPUs right now, I usually focus on the desktop market, and they can be incredibly expensive, especially if you want more VRAM. For example, like a 5060 Ti 16GB version, well over $500. So if you're looking at the desktop side of things, I still definitely recommend checking out the used market, like at Jawa.gg. For example, if you wanted something that is about as performant as a 5060 Ti, actually faster, but with more VRAM compared to the 8GB version, you could find one at Jawa for as low as $330 for a water-cooled version, or $380 for a non-water-cooled version. And there's a bunch of other GPU options available, but just saying, compared to like spending over $500 for less performance on a 5060 Ti 16GB version, that's a pretty good option. And huge thank you to Jawa for sponsoring this part of today's video. I can also get you $10 off your first purchase using code OWEN10. There's a sponsored link in the video description and or pinned comment. Now, they don't just have individual components. You can also get entire pre-built systems, target performance in specific games at specific resolutions, or even a theme that'll match your room, all sorts of stuff. And you can fund your upgrade by selling your old hardware at Jawa. You can go maximum convenience and get an instant offer selling directly to Jawa today for GPUs or CPUs, or you could become a Jawa seller, set your own price, create your own listings, all of that. There's tons of positive reviews. Again, check the link in the video description and or pinned comment. Now, back to the new GPU that we're getting today. So now this is laptops. Now I know a lot of my audience focuses on the desktop side of things, but like a huge amount of PC gaming happens on laptops. So this is actually a really big deal, because the RTX 5070 laptop GPU until now has been an 8GB card, which has all sorts of issues on games that would otherwise be fine for the amount of GPU power that you have. I have a video testing this out, showing that this is the case. So how are they doing this? Now, the 5070 laptop will now be available with 12GB of VRAM, but it's also going to be available alongside the current 8GB configuration. So this is going to be another one of those situations where there's two different specs with the exact same name, which I always feel like is a bit of a misleading for consumers kind of situation. In other words, you're going to need to be educated enough when looking up reviews and looking at laptop models, etc., to know whether you're getting the 5070 with the 8GB or the 5070 with the 12GB. Also remember that the 5070 laptop GPU is not as powerful as a 5070 desktop GPU. It's closer to like a 5060 Ti-ish type of performance, kind of in that ballpark, depending also on how much power the laptop gets it. This is one of the reasons why I don't review laptop GPUs. It's just there's so many variables that go into it. So it could be the same GPU, but give you different performance, and now it can give you different VRAM as well. So their official statement is that demand for GeForce RTX GPUs remains strong and memory supply is constrained. In order to maximize memory availability, we are releasing the GeForce RTX 5070 laptop GPU 12GB configuration with 24GB G7 memory. This gives our partners access to an additional pool of memory to complement the 16GB G7 supply that currently ships with most GeForce GPUs. The 12GB configuration will exist alongside the current 8GB configuration and allows our partners to bring a broader range of GeForce RTX 5070 laptops to consumers. So, if you're wondering how this works and how you get a 12GB VRAM version of the same GPU without changing anything else as the 8GB version, they did explain it right here. So basically, your GPU has a certain amount of memory bus, a certain number of bits. Like, think of it as how many lanes of memory stuff can connect to it. and the current one only supports a certain number of VRAM modules, and that number gets you 8 gigabytes of VRAM. But if each of those modules had more VRAM in it, but you have the same number of like connector slots, then you can then get up to a 50% increase if your modules go from being 2 gigabytes each to being 3 gigabytes each. So that's what's happening here. This is also what was rumored to be what was planned for a desktop super series of GPUs, but that those got indefinitely delayed, possibly canceled, due to the VRAM pricing going up. But the point is, Nvidia does have some access to supply of these 3 gigabyte modules. That's the 24 gigabit G7 memory. So they have some of these 3 gigabyte modules, and right now they only use them on a few GPU models and specifically in laptops. So what they're basically saying is if a laptop maker wanted to make a laptop with the 5070, they could now dip into the 3 gigabyte modules in order to do that, and that also then gets them 12 gigabytes of VRAM on it. Now, what we'll need to see is what is the price increase on all of this. So like how much more expensive are the 12 gigabyte 5070s compared to the 8 gigabyte 5070s in the same like otherwise, performance class of laptop. And again, when you're looking at laptops, you got to think about the how much thermal performance it allots to it, like how many watts can the GPU actually use, all of that. So laptops do get confusing, but overall, like performance-wise, I would feel a lot more comfortable buying a 5070 laptop with 12 gigabytes, even with no additional performance, just because of how many games are already right on that 8 gigabyte VRAM buffer, even if you're only playing at 1080p or 1440p. Now you can always reduce settings and make it work, but it's kind of nice to not have to do that when the GPU is otherwise powerful enough to run those settings. So this is a nice to see thing. I'll be curious if we get anything in the desktop space. There's still rumors that we'll see a 5050 with 9 gigabytes by doing the same type of thing, although that one's a little more complicated because they're switching the memory bus lower, but then jumping from GDDR6 to GDDR7 to make up for that bandwidth. But that's still in the leaks and rumors territory. Hey, since we're making a hardware news video today, how about we keep going? So we got a big post from Microsoft on their dev blog saying that they have announced Shader Model 6.10 preview and Agility SDK 720 preview. Now, these are actually a really big deal. Shader Model 6.10 introduces some huge changes to how games can work, how DirectX can work. Specifically, in my opinion, the biggest deal here is the lin-alg matrix. In other words, this allows the types of things that so far have been kind of vendor locked. So like upscaling with DLSS, it has been, one of the reasons it's been vendor locked is that the tensor cores aren't something that you could access through just a normal shader. If you're running like, I built my game in Unreal Engine and I want to do a normal shader and I want to access those tensor cores to do the AI upscaling, same thing with like FSR4 upscaling, that needs to kind of go through some more vendor-specific stuff. This is allowing those matrix accelerated machine learning tasks to be accessed directly through DirectX, which theoretically could mean that things like DLSS could become vendor agnostic. Now, I have my doubts on whether Nvidia will choose to do that, or even whether AMD would want to do that with FSR4, but it's certainly now a thing that could be accessed easier, or just other, game developers, if they wanted to spin up their own AI upscaler that just, runs on whatever matrix acceleration is available on your GPU. I mean, this gives them a way to access that, but also do other things within the game engine that are trying to do work with that matrix acceleration, linear algebra, which is how AI inferencing works. So this is, I think, a really big deal. There's some other changes here as well involving some ray tracing stuff, all sorts of things. You can dive into more detail here. But the other question with all of this is, are all of the new GPUs from the different brands compatible with these technologies. So that's what they have here. So that linear algebra accessibility is supported on AMD 9000 series products, but none of the earlier ones. Intel is planning support for an upcoming release, but Nvidia does support it on all RTX branded GPUs, so going all the way back to the 2000 series. Group Wave Index is supported on AMD's 7000 and 9000 series products, and support on Intel's Arc B series, but not A series. Nvidia doesn't support that at this time, but it's planned for an upcoming release. Variable group shared memory is supported on AMD 7000 and 9000 series products, but it's supporting a default memory limit size only, with higher size limits planned for future driver release. And Intel supports it fully, looks like, on their B series GPUs, and Nvidia supports it on all RTX hardware, but the values differ across the hardware. The ray tracing intrinsics, getting triangle object positions and cluster ID, is supported on AMD 7000 and 9000 series, Intel B series, and all RTX hardware. And batched asynchronous command list APIs are supported on AMD 7009 series, Intel Arc B series, and all RTX hardware. So I understand that for many of you, you're like, I don't really know what all of this is, but it's basically just, future things that games can access through DirectX, and which GPUs are going to be, future-proof regarding supporting that type of thing that games may start to want to take advantage of. That's how I would read that. Now, in other news, this is kind of cool. So this is a Steam update that, now this is really for more the developer side of things, but I'm looking at this more as something that I think could eventually end up as a public-facing thing to Steam users within the store. So look at this as something that might be a preview of something that Steam could be working towards that I think would be really cool. So lately, Steam has allowed users to opt in, you're not forced, to opt in to giving Steam access to performance data on your hardware. Now, right now, what they're using that for is Steam Deck compatibility, so that now game developers could actually look at average Steam Deck frame rate in their game, and you can track it by date, which is really interesting. So that if, for example, you published a new game patch and suddenly the average performance went down, that would be an interesting stat. But do you also see how this could be interesting if this became publicly facing information for a Steam user? And what if this was available for GPUs and CPUs rather than just the Steam Deck, right? So this could be interesting. Also, there's some feedback about Steam Deck Verified, and if you agree with it being verified, and if you disagree, is your reason for stability, input, performance, legibility, others. Anyway, so this could obviously be targeting for Steam machines as well once those launch. But like I said, long-term, looking forward, could this be something where it's kind of a part of almost like your Steam hardware survey? So if you opt in and Steam knows what GPU you have, it could publish frame rate data. Where that gets complicated, though, is with the Steam Deck, there's a specific GPU and CPU and memory configuration all tied together. It is one hardware platform. Whereas end users on Steam could have a GPU paired with you might have a strong GPU paired with a weak CPU, or a strong CPU paired with a weak GPU, or you could not have enough system memory and things like that. So in other words, this could be very complicated if you started to make this be publicly facing information regarding any given GPU. But at the same time, it could be interesting if they had a large enough data set, could you find people who have the same CPU and GPU combo? And things like that. So in other words, I could see this being an interesting way for things to go in the future, but there are definitely some complications with that. Now, another thing that's been in the news is the 9950 X3D2, which overall for gaming is kind of unreasonably expensive unless you're just trying to build the highest end system you possibly can and are completely unconcerned about value. However, a new top-end CPU launching can sometimes reduce the price of what used to be the top-end CPU. Now, there's an article here at videocards.com. By the way, all my sources will be linked in the video description today, as usual. That the 9950 X3D not 2 version, so where one CCD, so 8 of the cores, has the 3D V cache, but the other 8 don't, whereas the 9950 X3D 2 has the extra V cache on both CCDs, so all 16 cores. So the previous high-end flagship there maybe is being displaced a little bit on what sort of a price premium people are willing to pay. So it has now dropped a little bit in price. The evidence for this is a, looks like Amazon price history type deal, where you can see that it did recently just dip a little bit to a new low. So anyway, that's at least kind of a somewhat silver lining. Although if you're just doing a gaming build, the 9800 X3D makes a lot more sense. And honestly, even the 7800 X3D is often a better choice from a value proposition if you're going for high end, but not just throwing money at a problem with very little returns. Now, on the CPU side of things, though, and pricing, it's possible that things could start getting worse rather than better on CPU pricing. Now, we all know that memory pricing, which first affected RAM, but now is also affecting like flash storage, so SSDs. So SSDs and system RAM prices have gone through the roof. Components that use memory, like GPUs, prices have gone up, although not quite as through the roof, percentage-wise as just memory, since the entire product isn't memory. But CPUs could be affected next, not because they use memory, but because they're also part of this big data center build-out. So the reason that memory prices and SSD prices are, going through the roof is big data center build-outs for AI stuff, right? But agentic AI is also something that uses big CPUs, and just these big data center build-outs do also use CPUs. So CPUs are also potentially going to start seeing some issues where we're seeing lead times increasing to even the 1-year mark for these big server CPUs. But if AMD, Intel, etc. are able to make a lot of money on the data center CPU side of things, then it's possible that that can affect how much silicon they're willing to dedicate to the desktop CPU side of things, as well as, what sort of margins they would look for, right? That's where all of this is affected, right? Because if companies can make lots of money in data center, then they could shift their available production capacity towards data center. And we're seeing signs of CPUs creeping up and potentially being the next, desktop PC component that is affected in a major way by this. So this is still just kind of the early signs of that happening. But remember, we saw early signs of that happening to memory, and then things just got disastrous very quick, right? Now, there's also things that, muddy the waters on all this, which is how much of this is a true supply and demand hit versus, kind of opportunistic raising of prices and, blaming it on the AI data center side of things. And the reality of the situation is I think it's a combination of those. But just a heads up that there's signs that CPUs could start to climb as well. Now, speaking of CPUs, though, Intel has finally officially confirmed Arc G3 series for gaming handhelds. And I think that this could be a really big deal, at least until AMD finally updates their APUs for gaming handhelds. My biggest issue right now is I love handheld PC gaming. I use my Steam Deck constantly, but the original Steam Deck is a little bit weak for the more AAA games, especially as those newer games getting heavier and heavier. So there are more powerful handhelds out there than the Steam Deck, but a lot of them are still using AMD APUs that are still based on pre-RDNA 4 architectures, meaning you don't get access to FSR 4 upscaling. And honestly, with how expensive the PC handhelds are getting, I don't want to spend a huge amount of money upgrading to a PC handheld that's kind of using outdated tech that you know is very soon going to get replaced with modern upscaling with FSR 4. And on a handheld screen and with handheld power budgets, oftentimes you do want to upscale for performance reasons. But older versions of FSR don't look great, right? Well, Intel's Arc G3 series does support their high-quality, machine learning upscaling with XeSS 3. Intel also beat AMD to the punch with like multi-frame generation and things like that. So, anyway, the point is that they are officially talking about Arc G3 for PC handhelds. Now, the specs here could be very, very powerful. But we'll have to see what the price is because, as with all the other stuff right now, like memory components, SSDs are in there, so still might be a pretty bad time to upgrade your gaming handheld, but at the same time, could at least be a more modern platform to base it off of, and in general, having competition in that space, I think could only be a good thing. Now, speaking of Intel CPUs, though, in that same interview, I believe it was, or at least same series of kind of interviews, all my sources will be in the video description, Intel is also kind of defending some of their CPU performance and talking a bit about how it's not always just about the hardware. It's also about how the software uses the hardware and pushing back against some of the pushback that I guess Intel has received about their software optimizations to try to increase the performance of their CPUs in PC games. Here's some of the direct quotes from Robert Halleck. So, I truly believe, and this might get me in trouble, but I truly believe that the general PC gaming market, and especially enthusiasts, like really hardcore PC enthusiasts, are significantly underestimating the importance of software to the PC experience. Like really, really seriously. He continues, there is no game on Earth that is as fast as it's going to be purely through hardware. That doesn't exist anymore. That used to be the case in 2010 or 2015, but that's not how gaming works anymore. He continues, and that performance is, yes, you can make the game faster with a faster piece of hardware, but there's always going to be 10, 20, 30% performance hidden behind the fact that the game was just not optimized for your CPU. What gamers have literally asked me to do is like, hey, don't do this software thing. Just make faster hardware. And what they're really asking me is, hey, just leave 20% performance behind. Seriously, that is not the kind of business I want to run. So I'm interested in your guys' thoughts on this because I think there is something to this, like the way CPUs work now where there's a lot of like, predictions and branching paths and all sorts of things going on there. Like it's complicated how they work. If Intel can provide some sort of software level optimization that makes your game run faster, your game is running faster, right? So I think that that's not necessarily, wrong to say that we can optimize the games to run faster, so our games are running faster on our CPUs. I think, from my opinion, to be included as part of reviews, it basically just needs to be that software basically just needs to be part of your like chipset driver package. Like when you install this CPU and get it up and running, it needs to not really require anything from the end user. If this is something where the end user needs to go through and download some kind of optimization and apply it manually, that's where I don't think that counts as a true like CPU performance. But if this is just something that happens as part of installing the CPU and it just does it behind the scenes and the end user doesn't need to do anything, then I'm all for that being part of the CPU review, and it's just your CPU is running that game better because Intel did some work to make it run better, and great, it's running the game better. Now, on another software and hardware, interrelation note, there's some evidence now that the PlayStation 6 could run path tracing at 60 FPS as RDNA 5 was built for it, but mandatory handheld support threatens to hold it back. Now, that's the headline from WCCF Tech. What are they basing this off of? Well, I would say the headline is capturing some of the discussion here. I did go ahead and watch the full discussion here in this Digital Foundry Direct Weekly number 261. So you could follow that source as part of this big big video, one of their discussion points was a GDC presentation about F125 on the PS5 Pro, not the PS6, running path tracing at 30 FPS at 1080p upscaled to 4K. And I believe it was actually closer to running at 40 FPS when you actually look at the frame time in milliseconds. Now, one thought there is that the quality of that upscaling and how it compares to other games with more demanding scenes, because it was like a daylight scene in F125, so there's some questions there. But basically, the gist of the overall discussion is that there's still a lot of software optimizations available for path tracing. Path tracing is a fairly new technology as far as gaming technologies go. And so usually your first iteration of doing something is not necessarily the most optimal way of doing something. And in one of my previous hardware news videos, I talked about the Nvidia white paper talking about making path tracing, a lot more performant, while actually not producing worse quality, but better or similar or better quality. So this one is not talking about that NVIDIA optimization, but talking about something that EA is doing in some of their own path tracing research. So the point is, I would say, is there is a lot of evidence that further software optimizations to path tracing can combine with further hardware optimizations for path tracing to make path tracing in the next generation of GPUs and consoles potentially something that is a lot more viable as like the default way to play and run a game, whereas right now it really is usually just the highest of high-end hardware that makes it a reasonable thing to do. Like I said, if you want to follow up more on this discussion, sources will be in the video description. But speaking of PlayStation, there's some evidence that they're bringing in a new DRM policy that is reminiscent of one that Xbox announced that PlayStation mocked them for back in 2013, where basically your digital games will have to check in online once every 30 days, or else you lose access to them. So sorry if you bought a game when you had an internet connection, you downloaded it, and then now you don't have an internet connection for whatever reason. Maybe you moved, maybe you gave the console to somebody else. Who knows what the reason is? But apparently you will need to check in online every 30 days, or else your online or your digitally purchased game will not be playable. Now, this has been verified as not a bug by PlayStation customer support. And also there was at least one person on YouTube who cleared their CMOS cache on their PlayStation to basically reset its check-in process, and it did indeed stop you from booting the game. So it's not just a countdown that won't actually be enforced. You cannot start the game if that timer needs to be refreshed. I don't like increasing that kind of DRM practice on these games because you purchased the game. I don't think you need to check in every 30 days online in order to play it. I think that's just annoying and, again, reducing the rights of the end user. Also in PlayStation news, they had already raised their PS5 and PS5 Pro prices all over in many places in the world. Southeast Asia has now also received a price increase. You can see Singapore, Malaysia, Thailand, Indonesia, Philippines, Vietnam, etc. here for the new pricing. And again, blaming on the memory situation, all of that, as far as the reasons. Now, this video is getting rather long, so let's quickly wrap up some other news topics here. So Xbox has confirmed that Project Helix pricing and availability could also be affected by memory shortages, and they're just focusing on developing the best console that they possibly can within what they can control, but launch timelines and things like that will probably be sort of a play-it-by-ear dynamic situation is sort of the way I'm reading this. The official quote is, all of these things are an equation. Memory costs will impact pricing, will impact availability. As we think about being where the world plays, we will take that into consideration. So we're not ready to share a launch timeline right now. The world's pretty dynamic. My number one focus, though, is to focus on what's in our control. build a great console to play great games, including your PC games. So they're still doubling down that this will be a console to play console games, but also also playing PC games. Anyway, so interesting quote. Also, Xbox says Project Helix will lead in performance for console and PC games. I can't believe that they mean it will actually lead PC gaming performance compared to something like a 5090 or if a 6090 is out by then. So interesting. Hey, what about Steam hardware? Well, in their discussions regarding the Steam controller launch, they're also talking about getting questioned about the Steam Deck 2, and they're saying that they are hard at work on Steam Deck 2, but there's still no specific release window. My guess is they're waiting until AMD has new APUs out there that have like FSR4 support and things like that. That's what would make sense to me. Although Proton is getting an update to help with Marvel's Avenger fixes, and the Steam controller has been launched, or at least coming soon, availability on May 4th, at $99. Now, it has a lot of good features, and I would point you towards the Gamers Nexus review as a good option here. Sorry, I didn't mean to actually play the video, where they test things like latency when you have a bunch of, like up to 7 controllers connected to the puck, versus when they're connected to Bluetooth, etc. So cool testing here from Gamers Nexus, including the thumbsticks, which aren't quite Hall Effect. They're kind of a Hall Effect-like thing called TMR, which was really interesting. So I'd point you towards that Gamers Nexus video. And once again, don't forget to check out jawa.gg and use code OWEN10. You can click the link in the video description and or pinned comment. I hope all of you have an excellent day.